So morning we had seen the properties of convolution. So we had seen commutative property and distributive. So now we shall check about associative property. So distributive property is nothing but if h of n and h1 of n and h2 of n are in parallel, you can write it as h1 of n plus h2 of n. Okay. Similarly, if the two systems are connected in cascade or series, you can write h1 of n convolved with h2 of n. So if they are in series like this, you can write h1 of n convolved with h2 of n. If they are in parallel, you can write h1 of n plus or minus h2 of n. Okay, let us start associative property of convolution. So it states that x of n convolved with h1 of n, which is convolved with h2 of n, is equal to x of n convolved with h1 of n convolved with h2 of n. Okay, so let us consider this as our f1 of n and this as f2 of n. Okay, let us write what is f1 of n and f2 of n. f1 of n is nothing but x of n convolved with h of n, and f2 of n is h1 of, this is h1 of n. f2 of n is h1 of n convolved with h2 of n. Okay, so now let us write it in the form of convolution sum. You have summation m is equal to minus infinity to infinity x of m into h1 of n minus m. Okay, now I'll take f2 of n and write it in the form of convolution sum. So you have summation of r is equal to minus infinity to infinity h1 of r into h2 of n minus r. Okay, I have split this and kept. Now I'll take LHS and try to prove the RHS. Okay, is it visible, everyone?
Yes, ma'am.
Okay, so here I have taken m as the variable for f1 of n. I have taken r as a variable for f2 of n. Okay, so I'll take LHS now. Our LHS is x of n convolved with h1 of n convolved with h2 of n. As you can see, we have put a bracket to the first two terms in the in this, and here we have put for the second next two terms. Okay, h1 of n, h2 of n. Here we have put bracket for x of n and h1 of n. So this x of n convolved with h1 of n is f1 of n convolved with h2 of n. So I can write it in the form of convolution sum as summation k is equal to minus infinity to infinity. So k is equal to minus infinity to infinity f1 of k into h2 of n minus k. Okay, so now what is this f1 of k? Nothing but f1 of n. Just replace n with k and write the same, this one. Okay, so we have summation k is equal to minus infinity to infinity. So what is f1 of k? It is nothing but what is f1 of n. Okay, we are replacing n with k here. That's it. So you have summation m is equal to minus infinity to infinity x of m into h1 of n minus m into h2 of n minus k. Okay. So now what we shall do is we shall separate these terms. Summation m is equal to minus infinity to infinity x of m into convolution of into summation of k is equal to minus infinity to infinity h1 of n minus m into h2 of n minus k. Okay. Now you substitute k minus. Sorry, this is k. Okay, because we are replacing n with k. Okay, h1 this one in this equation we are replacing n with k. f1 of n is nothing but f1 of k. So it is x of m into h1 of k minus m here. Okay, so it's h1 of k minus m. So let us substitute this k minus m as some variable r. So if you substitute like this, so if k is equal to minus infinity, what is r? What is R if k is minus infinity?
Infinity.
It will be infinity. Okay. Now, wait. If k is minus infinity, what is R?
Minus infinity.
It will be minus infinity only, right? So minus infinity minus m will be minus infinity. Okay. So if k is equal to infinity, what do you get? R is equal to plus infinity you will get. Okay. So summation of m is equal to minus infinity to infinity x of m into summation we have taken r is equal to minus infinity to infinity h1 of r, okay, I am replacing k minus m with r into h2 of, so what is k here? K is equal to r plus m. So h2 of n minus r minus m. Got it, everyone? Is this step clear?
Yes, ma'am.
Everyone, it's clear. So now we know what is f2 of n. Okay, f2 of n is summation r is equal to minus infinity to infinity h1 of r into h2 of n minus r. So if I take f2 of n minus m, wherever you have n, will replace with n minus m. Okay, this is f2 of n. So f2 of n minus m would be equal to summation of r is equal to minus infinity to infinity h1 of r into h2 of n minus m minus r. Just we are replacing n with n minus m in f2 of n. Okay. So what are we left with? So we have summation m is equal to minus infinity to infinity x of m. And what is this? f2 of n minus m is your this term from here to here. Summation r is equal to minus infinity to infinity h1 of r into h2 of n minus r minus m. It's the same, these two. So we can write summation m is equal to minus infinity to infinity x of m into f2 of n minus m. Okay. So using convolution sum, we can write it as x of n convolved with f2 of n. So our f2 of n is nothing but h1 of n convolved with h2 of n. So it is x of n convolved with h1 of n convolved with h2 of n. Understood, everyone? Which is equal to your RHS. Clear? Is it clear, guys? You want me to explain once again?
Yes, ma'am.
So associative property of convolution is x of n convolved with h1 of n convolved with h2 of n is equal to x of n convolved with h1 of n convolved with h2 of n. So brackets are put for first two terms here and next two terms here. Okay, first and second term for this, and for this first and second here and second and third term here. So now let us take what is there in this bracket as f1 of n and what is there in this bracket as f2 of n. Okay, f1 of n is x of n convolved with h1 of n. Using the convolution sum equation, you can write it as summation m is equal to minus infinity to infinity x of m into h1 of n minus m. I have taken some variable m here. Okay, whereas for this is f2 of n. It is h1 of n convolved with h2 of n. I take one variable r and write it summation of r is equal to minus infinity to infinity h1 of r into h2 of n minus r. So write this much and proceed to the LHS, take the LHS, and using this LHS we'll try to prove RHS. So LHS is x of n convolved with h1 of n convolved with h2 of n, where we have brackets for first two terms. So this is our f1 of n. Okay, f1 of n convolved with h2 of n. Now apply convolution sum equation for this. So summation k is equal to minus infinity to infinity f1 of k into h2 of n minus k. We are using the variable k and using and we are writing in terms of convolution sum here. Okay, so and we know what is f1 of k. f1 of k is f1 of n only. Just replace n with k. Okay, so in this equation f1 of k equation is this. Okay, So just replace n with k here and write the same. Summation k is equal to minus infinity to infinity. F1 of k is nothing but F1 of n equation. We are replacing n with k. That's it. Summation m is equal to minus infinity to infinity x of m into h1 of k minus m. Here you have n minus m. We are replacing n with k. So we have h1 of k minus m into h2 of n minus k. This is as it is, you put it. Next, we'll try to group the terms with this. So summation m is equal to minus infinity to infinity x of m. Take this outside, and you have summation k is equal to minus infinity to infinity h1 of k minus m into h2 of n minus k. So what you have to do is take this k minus m and replace it with r. Okay, h1 variable k minus m should be replaced with r. So if you are replacing k minus m with some new variable r, so if k is equal to minus infinity, what is r? Minus infinity minus m. R will be minus infinity itself. If k is equal to plus infinity, so it will be infinity minus m, which will be r will be minus plus infinity itself. Okay. So we are substituting lower limit here in place of k and upper limit and trying to get the new variable limits. Okay. So we have the same limits minus infinity to infinity only. Summation m is equal to minus infinity to infinity x of m into summation r is equal to minus infinity to infinity h1 of r, because k minus m is r, and h2 of, what is the equation for k? R plus m. So h2 of n minus of r plus m. Okay, so I have written directly, you will have h2 of n minus of r plus m. So I have written h2 of n minus r minus m. Okay, just replacing k with r plus m, because you have minus k, it will be minus r minus m. That's it. Next, we shall see what is this f2 of n minus m. We have already f2 of n. So f2 of n is summation r is equal to minus infinity to infinity h1 of r into h2 of n minus r. Suppose if I replace this n with n minus m, so f2 of n minus m would be summation r is equal to minus infinity to infinity h1 of r into h2 of n minus m minus r. Okay, so that is your f2 of n minus m. Okay, we are replacing n with n minus m. We get the same equation. So we can write this whole term as f2 of n minus m. That is what we have done. So you have summation m is equal to minus infinity to infinity x of m into f2 of n minus m. So this is the convolution sum equation. That is x of n convolved with f2 of n. So you get x of n. What is our f2 of n? Previously we have seen it is h1 of n convolved with h2 of n. So that you replace. X of n convolved with h1 of n convolved with h2 of n. Got it, everyone? Clear? It's clear or not? Is it clear, guys?
Yes, ma'am.
What about others? It's clear?
Yes, ma'am.
Yes, ma'am.
So next you take down associative property for convolution integral. Associative property for convolution integral. Okay, so x of t convolved with h1 of t, I'll put a bracket for this, convolved with h2 of t is equal to x of t convolved with h1 of t convolved with h2 of t. Okay, so we have put bracket for first two terms and here for the second and third term. So x of t convolved with h1 of t convolved with h2 of t is equal to x of t if you convolve with h1 of t convolved with h2 of t. If you convolve these two and convolve with this, you get the same. If you convolve these two first and convolve it with h of x of t. Okay, so that is the meaning of this property. So now we'll try to prove this. Okay, so this x of t convolved with h1 of t, I'll write it as f1 of t, and this I'll write it as f2 of t. Okay, so f1 of t is equal to integral minus infinity to infinity. I'll take some variable m. M is equal to minus infinity to infinity. So integral limits are m is equal to minus infinity to infinity x of m into h1 of t minus m into dm. Okay. Next, I'll write f2 of t now. f2 of t is integral limits. I'll take r here, similar to previous. R is equal to minus infinity to infinity. X of, sorry, we have h here, right? So it's h1 of r into h2 of t minus r into dr. Got it, everyone? Clear? I'm writing these two in the form of convolution integral, f1 of t, f2 of t. Clear? It's clear or not?
Yes, ma'am.
So we'll take the LHS and try to prove the RHS. So what is our LHS? Our LHS is f1 of t convolved with h2 of t. So we'll try to write in the form of convolution integral. So we'll take tau is equal to minus infinity to infinity f1 of tau into h2 of t minus tau into d tau. Okay, so we are writing this in the form of convolution integral f1 of t convolved with h2 of t. So now we know what is f1 of tau, right? That is f1 of t. So we'll replace t with tau. Wherever you have t term, we'll replace it with tau and write this f1 of t term here. So integral, you have tau is equal to minus infinity to infinity. Integral m is equal to minus infinity to infinity. X of m into h1 of tau minus m into dm into h2 of t minus tau into d tau. Got it, everyone? Clear? This is f1 of t. Okay, t we are replacing it with tau. You get this much. Got it? Is it clear?
Yes, ma'am.
So tau minus m is equal to r. Okay, this tau minus m, I'll replace it with some variable r. So if you replace it with r, first let us rearrange this. Okay, so tau is, I'll write x of m. So m is equal to minus infinity to infinity, and we have x of m. Integral tau is equal to minus infinity to infinity. You have h1 of tau minus m into h2 of t minus tau into dm into d tau. This is what we have. Now in this step, I'll replace this tau minus m, which is with r. Okay, tau minus m is equal to r. So if tau minus m is equal to r, so if I differentiate this equation with respect to tau, so this will be 1 minus 0, which is equal to dr by dm. So if you differentiate tau with respect to d tau, you'll get 1. If you differentiate m with respect to d tau, you get 0. And if you differentiate r, you get dr by dm. Okay. We are differentiating it with respect to tau. Sorry, it's not dm, d tau. We are differentiating this equation with respect to d tau. Tau. Okay. So your d tau will be equal to dr. Okay. So let us substitute these. So what is the equation for tau? Tau is nothing but r plus m. You remember this? So we have integral m is equal to minus infinity to infinity x of m into integral r is equal to minus infinity to infinity h1 of r into h2 of t minus r minus m into dr into dm. Okay, got it, everyone? Clear? When tau is equal to minus infinity, r is equal to minus infinity. When tau is equal to infinity, r is equal to infinity. Got it? Understood everyone? Here tau minus m we are replacing it with r and we are replacing d tau with dr. Okay. And in place of tau we are putting r plus m. So t minus of r plus m is t minus r minus m. Clear? Is it clear? So we have seen what is f2 of t, right? f2 of t was r is equal to minus infinity to infinity h1 of r into h2 of t minus r. So if we want to write f2 of t minus m, so what it will be? R is equal to minus infinity to infinity h1 of r into h2 of t minus m minus r into dr. Yes or no? Using this, so we can equate. So we have this with respect to f2 of t. So this resembles f2 of t minus m, this whole equation. Yes or no? In f2 of t, I am replacing t with t minus m. That's it. Okay. So you have integral m is equal to minus infinity to infinity x of m into f2 of t minus m into dm. Okay. So you, sorry, till here, not fully. Yeah, this we are replacing it with f2 of t minus m. Okay, this dm is as it is. So this is the equation for convolution integral. So we can write x, it is x of t convolved with f2 of t. Okay, this is your RHS. So what is f2 of t? f2 of t is h1 of t convolved with h2 of t. So you get x of t convolved with h1 of t convolved with h2 of t. Got it everyone? This is our RHS. Clear? Same as convolution sum only, just you have integral here. Clear everyone? You have any doubts?
Ma'am, can you scroll little bit down?
Yes.
Down, ma'am, down.
Just a minute. Clear? You want me to explain once again? You want me to brief up once again? Yes, guys, tell me yes or no. Did you follow?
Yes, ma'am.
If you want me to explain once again, I'll explain once again. Okay, listen carefully. They might also ask you properties of convolution. So that time you can prove whatever you want. Convolution integral or sum, associative properties with sum or integral. So if they specifically ask you integral, you show this only. So x of t convolved with x of t convolved with h1 of t convolved with h2 of t is equal to x of t convolved with h1 of t convolved with h2 of t. So if you convolve these two first, then next two, if you convolve h2 of t, it will be the same as convolving h1 of t, h2 of t first, then convolving it with x of t. Okay. So we'll take this term as f1 of t and this as f2 of t. So we know we have continuous time signal. So it is convolution integral. Write the equation for convolution integral. So let the variable be m here and r here. Okay. So you have integral minus infinity, m is equal to minus infinity to infinity x of m into h1 of t minus m into dm. Here you have integral r is equal to minus infinity to infinity h1 of r into h2 of t minus r into dr. Now we have got what is f1 of t and f2 of t. Keep them as it is. Now let us take LHS and try to prove RHS. Your LHS is f1 of t convolved with h2 of t. This is a convolution integral, right? So I'll take tau is equal to minus infinity to infinity, integral minus infinity to infinity, f1 of tau into h2 of t minus tau into d tau. Now we know what is f1 of tau. It is f1 of t only. We are replacing t with tau. That's it. So integral tau is equal to minus infinity to infinity into integral m is equal to minus infinity to infinity x of m into h1 of tau minus m into dm. Here we have t minus m, tau minus m. Just f1 of t is replaced with f1 of tau. T is replaced with tau here. and this term is as it is, h2 of t minus tau into d tau. Now you can write it, put this x of m term one side and put this tau integral with respect to tau one side. So integral m is equal to minus infinity to infinity x of m into integral tau is equal to minus infinity to infinity h1 of tau minus m into h2 of t minus tau into dm into d tau. So what we have to do is we have to replace this tau minus m with r. Okay, so if you replace this tau minus m with r, if tau is equal to minus infinity, r is equal to minus infinity. If tau is equal to infinity, r is equal to infinity. If you differentiate this with respect to d tau, so you get 1 minus 0 is equal to dr by d tau. M is a constant if you take d tau, right? If you differentiate it with respect to d tau, so you get d tau is equal to dr. So replace tau with r, next step, and tau is equal to r plus m. Okay, tau is equal to r plus m. This m minus m will go to the other side, it will be r plus m. So integral m is equal to minus infinity to infinity x of m into integral r is equal to minus infinity to infinity h1 of r into h. We are replacing tau minus m with r. So you have h1 of r into h2 of t minus r minus m, because in place of tau we are putting r plus m. So t minus of r plus m or t minus r minus m into dr, because d tau is replaced with dr and dm is as it is. Clear? So we have seen what is f2 of t, right? Previously we have h1 of t converted with h2 of t. So we can write it as integral r is equal to minus infinity to infinity h1 of r into h2 of t minus r. So if I replace t with t minus m, so I'll get integral minus infinity to infinity h1 of r into h2 of t minus m minus r. So this resembles this equation which is f2 of t minus m. So we can write integral minus infinity to infinity x of m into f2 of t minus m into dm. Okay, only this much it is f2 of t minus m. So dm, put it as it is. So this is our convolution integral x of t convolved with f2 of t. Okay, f2 of t is h1 of t convolved with h2 of t. So this is our RHS. Clear, everyone? It's clear?
Yes, ma'am.
So before now we shall solve few problems on interconnection. Okay. Okay, I'll just say you few properties. You have some small properties. So that is for your reference. So property of delta function. Property of delta function, just you have the properties. Okay. So if delta n or delta t is an impulse signal, then if you convolve x of t with delta t minus t1, it would be x of t minus t1. Okay. Similarly, if you convolve x of n with delta n minus n1, it will be x of n minus n1. Just remember this. Okay. It's not so important. And you have some time delay property. That is what we have seen that day in convolution of delayed unit response. Okay. So that is if you convolve delta of n minus k, if you convolve it with delta of n minus m, we'll get delta of n minus m plus k, which is equal to delta of n minus m minus k. This we have used for one type of solving problems on convolution sum. Did you solve those problems? Homework problems, everyone? Did you solve it?
Yes, ma'am.
So I'll tell you the answers, you just verify those. So I had given you one problem where your h of n was equal to u of n minus u of n minus 10 and x of n was u of n minus 2 minus u of n minus 7. So did you all do this? So your h of n was a signal which was existing from 0 to 9. 6, 7, 8, 9. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. And x of n was equal to, it will be existing from 2 to 6. So from 0 I told you to take, right? 0, 0, 1 at n is equal to 0, n is equal to 2, 3, 4, 5, 6. So this is your origin. So what did you get? Can you tell me the sequence? Y of n, what you have got?
0, 0, 1,
Yeah.
2, 3, 4, 5, 5, 5, 5, 5, 5, 4, 3, 2, 1, ma'am.
Yeah, correct. 0, 0, 1, 2, 3, 4, followed by 6 zeros, sorry, 6 fives. Yeah, 4, 3, 2, 1. Did everyone get the same?
Yes, ma'am.
Okay. So next problem, I had given you one more problem. X of n is equal to 1, 2, 3, 4. I think this is that problem of simple method which I had shown you, right? It's 1, 5, 1. So the origin will be here for this previous sum, right? Because to the left of n is equal to 0, you don't have anything. So it's here only, origin. So for this, I think you people have done this in simple method. So did you get this? Y of n is equal to 1, 7, 14, 21, 23 and 4. Your origin is at 14. So this was, origin is at 2 and for this it was at 5. So 1 plus 1, it is 2. Got it?
Yes, ma'am.
Okay, I have given one more problem, right? X of n is equal to 1, 1, 1, 1, 1. 5 ones and origin was here. And h of n was equal to, so this is only h of n. This is our h of n and x of n was equal to 1, 1, minus 1, minus 1. This was the origin for this first term. First term was the origin. What did you get the answer? Y of n? Tell me.
1, 2, 1, 0, 0, minus 1, minus 2, minus 1. Ma'am.
Yes, 1, 2, 1, 0, 0, minus 1, minus 2, minus 1. Did everyone get the same? And where will the origin be?
Second one.
2, ma'am.
At 2. Did you all get the same for this problem?
Yes, ma'am.
Okay. Other problem I had shown you in that PDF. I hope you have done that. Right? So no need of that. So these are the problems on convolution sum using the property method. So this method you do. If they don't mention any method, if they ask you for convolution sum, if they don't mention if they didn't mention anything, you do this property method. If they mention graphical method, then do graphical method. You can use simple method for verification of the results. Okay. So that is about this, and we have to solve problems on interconnection, right? Okay. So take down first problem. This is problems on interconnection of LTI systems. It's the same in unit 2 and unit 3. So find the overall impulse response h of t.
Ma'am, can you repeat again? These are problems on, ma'am?
Interconnection of systems.
Interconnection. Okay. Fine.
So morning we had seen, right, connection in parallel, two systems in parallel, two systems in series or cascade. This is problems on that. Okay. So find the overall impulse response h of t in terms of impulse response of each subsystem shown in figure. Okay, so take down the diagram. You have x of t, and it's given to three subsystems. This is h1 of t, then you have h2 of t, and you have h3 of t. Now you have cascading of h1 of t with h4 of t, whereas these two are added. Now you are adding these two. Plus minus. Okay, you have minus sign here, and you have h5 of t, which is equal to y of t. Can you write the equation for this h of t equation? What you get? So you can see x of t is given to three systems, h1 of t, h2 of t, h3 of t. Okay, and h1 of t and h4 of t are in series, and you can see h2 and h3 are in parallel, and you have h5 of t here. So how do you write this? H of t. They're asking you overall impulse response h of t. So you have to reduce the systems in series and parallel, and you have to write the equation. It is simple. Okay. So first, h1 of t and h4 of t are in series, right? So if you are having series, what will you write? How will you replace this? If two systems are in series, how will you write that?
h1 of t convolved with h2 of
h1 of t convolved with h4 of t. Okay. And here you have minus sign. So what about these two? Minus, what is this? If you have two systems in parallel, how will you replace them? If these two are in parallel, how will you reduce them? Minus h2 of t plus h3 of t. You have both plus signs here, right? So h2 of t plus h3 of t. Then we have subtracted this term, this whole term, right? h2 of t plus h3 of t, minus of h2 of t plus h3 of t. Now you have h5 of t in series with this. So what will you write? Convolved with h5 of t. Got it? Clear? Is it clear?
Yes, ma'am.
So these two are in series. If you have in series, you will be writing a convolution symbol between h1 of t and h4 of t. These two are in parallel, you will be writing a plus symbol, plus or minus if they're in parallel, h2 of t plus h3 of t. Now these two are in parallel. This is parallel with this. So you'll write plus or minus, right? You have plus here and minus here. These signs will be given to you. Okay, this plus or plus minus. So h1 of t convert with h4 of t minus h2 of t plus h3 of t convert with h5 of t. These system is in series with h5 of t. So it's convert with h5 of t. Got it, everyone? Clear?
Yes, ma'am.
So they might give a problem like this. They'll give you a system and tell you to write the impulse response equation for h of t. Or there is one more method. They'll give you the equation and they'll tell you to write the subsystem. So take down next problem. Let h1 of t, h2 of t, h3 of t, h4 of t be the impulse response of LTI system. Draw the interconnection of systems. Draw the interconnection of systems required to obtain the overall impulse response. Okay. Okay, so they'll give you the equation. You have to draw the interconnection of systems accordingly. So take down the equation. H of t is equal to h1 of t
Ma'am, in
plus
previous problem, x of t should write, ma'am.
what?
X of t. Should we write or not in previous one?
They're asking you just h of t, right? So this is enough. If they ask you y of t, then you write x of t convolved with this whole thing, h of t. These thing you replace it in place of h of t. Got it?
Yes, ma'am.
Here also they're asking you to find the overall impulse response only. H of t, yeah, this is drawing the interconnection of systems. So h of t is equal to h1 of t plus h2 of t plus h3 of t convolved with h4 of t. So try drawing this, draw the interconnection of systems for this one. I'll show one and I'll give you some two. You try it by yourself. So we'll take we have to take x of t for this. So we have h1 of t parallel to h2 of t parallel to h3 of t convolved with h4 of t. So let us see how it will be. So you have x of t and this is h1 of t that is in parallel with h2 of t and h3 of t, h2 of t and h3 of t. So this is the summation plus plus. Now this whole thing, wait. So there is a bracket for this. So now you will write convolution h4 of t. H2 and h3 are in parallel and series with h4 of t. So you write h4 of t and sum it up so that you will have your y of t. Understood? Got it?
Yes, ma'am.
Okay, so this is interconnection of systems. You have to know series and parallel. That's it. For series, you will have convolution symbol. For parallel, you will have plus or minus. You understand that much? So wait. This is plus and plus. Okay. So h1 of t is parallel with these h2 of t plus h3 of t. That is h2 of t and h3 of t also are in parallel. And it is series, it is in cascade with h4 of t or in series with h4 of t, and these two are in parallel with each other. Got it? So I'll give you two more problems. Try that. H of t is equal to h1 of t convolved with h2 of t plus h3 of t. I have shared your textbook PDF. I've taken these problems from there only. You can refer the same. H4 of t. This you try and you take h of t is equal to h1 of t convolved with h2 of t plus h3 of t convolved with h4 of t. You try this.
Ma'am, is there any bracket for the last one, ma'am?
No, there is no bracket. Directly they have given like this. You try these two. So these two are in parallel, h2 of t, h3 of t. For h2 of t, you have h1 of t in series. For h3 of t, you have h4 of t in series. That's all. Got it? Is it clear?
Yes,
Clear, everyone? So this is with respect to continuous time. I'll give you one with respect to discrete time. We'll try to solve that. Consider the interconnection of LTI systems depicted in the figure. So the impulse response of the impulse response of each system is given as so h1 of n is equal to unit step u of n, h2 of n is equal to u of n plus 2 minus u of n, h3 of n is equal to delta of n minus 2, and h4 of n is equal to alpha to the power of n into u of n. Find the overall impulse response of the system. Find the overall impulse response of the system. They'll give you the diagram also. I'll write the diagram. You have x of n and you have two branches. One is this is h1 of n, this is h2 of n, and you have h4 of n here, h4 of n. So these two are added together, h1 of and h2 of n, h1 of n and h2 of n. Then it's in series with h3 of n. So this whole thing is added again. So it is equal to y of n. So you have to reduce this system, okay, and write an equation. After that, you try to solve that equation by substituting the values of h1 of n, h2 of n, h3 of n, and h4 of n. Got it? So shall we try to solve this? This is the given problem. X of n is given to h1 of n, h2 of n, h4 of n. h1 of n, h2 of n are in parallel, and that is in series with h3 of n, and these h1, h2, h3 is in parallel with h4. That's all. Try to reduce this and get the equation. Did you all understand the problem?
Yes, ma'am.
Others following the problem?
Yes, ma'am.
Okay. So try to get an equation for this. These two are in parallel, add them. This is in series, convolve them. Then you have this h4 in parallel, so add it. We'll get an equation. H of n is equal to h1 of n plus h2 of n. Okay, that is convolved with h3 of n plus h4 of n. Got it, everyone? You reduce it and write. You will get two steps. Two diagrams. First, you reduce this, then write a convolution along with that. Then you reduce this. Got it? Now let us substitute the values of h1, h2, h3, h4. They have given us h1 of n is unit step, h2 of n is u of n plus 2 minus u of n, h3 of n is delta of n minus 2, h4 of n is alpha to the power of n into u of n. Okay, substitute and try solving. What will you get? You tell me. H of n is equal to h1 of n. So that h1 of n is u of n. And h2 of n is u of n plus 2 minus u of n, convolved with h3 of n, which is delta of n minus 2 plus alpha to the power of n into u of n. So this u of n and this u of n will get cancelled. So if you convolve this u of n plus 2 with delta n minus 2, what will you have? What will you have if you convolve this u of n plus 2 with delta of n minus 2? We have seen a property right previously. So if you have x of t, if you convolve with delta t minus, sorry, I'll take discrete time. Okay, let it be. If you have x of t, if you convolve with, if you have x of n, if you convolve it with delta of n minus n1, what will you get using this property? You'll get x of n minus n1. Similarly, you have u of n plus 2 in place of x of n. If you convolve it with delta n minus 2, what will you get? This is your x of n. This is delta. What do you get if you convolve these two?
U of n minus 2.
What about n plus 2? What about this plus 2? So you'll have u of n minus 2 plus 2. Did you follow? So here I have, take this example, x of n minus n naught convolved with delta n minus n1. What will you write? X of n minus n naught minus n1, correct? Yes or no?
Yes, ma'am.
So you will have u of n minus 2 plus 1 plus alpha to the power of n into u of n. Minus 2 plus 2 gets cancelled. You are left with u of n plus alpha to the power of n into u of n. Take u of n common, you will get 1 plus alpha to the power of n, which is your h of n. Got it? Clear? So what is y of n? Y of n is x of n convolved with h of n. You can write this x of n convolved with u of n into 1 plus alpha to the power of n. Got it? They are asking you to find overall impulse response of the system. So this much would be enough. This you can write it. Got it, everyone? Clear?
Yes, ma'am.
Others clear? Shall we check it once again? They are giving you interconnection of LTI systems. This figure is given. And they are giving you what is H1, H2, H3, H4 of n. Okay. You have to find the overall impulse response of the system. That is H of n you have to find. Okay. So first what you will do is you try to reduce this parallel series and try to get the equation. After getting the equation, substitute these values of H1, H2, H3, H4 and try to use this. You can, whichever you can cancel, you can cancel. You have this property. Use the property and try to reduce it. U of n plus 2 convert to delta n minus 2 is u of n minus 2 plus 2. Okay, because it's of the form x of n minus n naught convolved with delta n minus n1, which is equal to x of n minus n naught minus n1. Okay, add the delays plus alpha to the power of n into u of n. This 2 and this 2 gets cancelled. You have u of n plus alpha to the power of n into u of n. So if you take u of n common, h of n is u of n into 1 plus alpha to the power of n. You can write it in the form of y of n. Convolution sum. X of n converted with h of n is x of n converted with u of n into 1 plus alpha to the power of n. Got it? Clear?
Yes, ma'am.
So that is about interconnection of systems and system properties. So interconnection of systems, it is in unit 3 as well as and unit 2 also. It's the same. You have to solve like this: systems in series, systems in cascade, parallel. Sorry, systems in series or cascade, systems in parallel. Reduce it and you have to write the equation, or if they give the equation, write the diagram for this, figure for this. Okay, that is about interconnection of systems. Differential, we will solve it. Before that, we have a topic in Unit 3. Okay. Till here, clear everyone? Is it clear?
Yes, ma'am.
Do you have any doubts till here? Till here, is it clear everyone?
Yes, ma'am.
So I have shared the textbook PDF also. You have some more problems also in interconnection and all. You try to solve that. So let us go to the next topic. Categorization of LTI systems based on impulse response. Okay, so we have seen system classification in our unit 2, right? We had classified systems based on linearity, causality, memory, time invariant or time variant, stable, and invertibility. So you have categorization of LTI systems based on impulse response. That is, you have to check for causality, memory you have to check, and you have to check stability. So with respect to LTI systems, you have to check the categorization of LTI systems with respect to these three properties of systems. Okay. So as I have told you, in your system classification, we had seen different types of systems, right? 6 types of systems. And how did you categorize that? Based on the input and output relationship, you categorize those systems, right? Input-output relationship was given to you. And you classified the systems based on linear, non-linear, memory, memoryless, causal, non-causal, right? So now let us categorize the systems depending upon the impulse response. Okay. So that is memory, causality, stability. These three you have to classify. So impulse response will be given to you, h of n or h of t. It will be some signal given to you. So you have to categorize that signal based on causality, memory, and stable. So let us see the conditions for how we will categorize it as causal, non-causal, memory, memoryless, stable, unstable. If you are being given with h of t, h of n, you have to classify this h of t or h of n, some signal will be given. That you have to check if it's memoryless or memory, causal, non-causal, stable, unstable. Okay, clear everyone? Is it clear? Shall we start with this categorization of LTI system based on impulse response? Did you get some idea on this?
Yes, ma'am.
Okay, so let us see first memory categorization. So a system is said to be memoryless if the impulse response satisfies this condition. So h of n is equal to 0 for n not equal to 0 for discrete time signals, okay, or h of t is equal to 0 for t not equal to 0 for continuous time signals. Okay, so if these two conditions are satisfied, the system is memoryless. Okay, so h of n should be equal to 0 for n not equal to 0. What is the meaning of this? What is the meaning of this? H of n should be 0 for n not equal to 0. What's the meaning? At n is equal to 0, it can have some amplitude, but for n not equal to 0, that is for all the negative values from 0 up to minus infinity, and from 0 to infinity, the amplitude should be 0. That time it's called memoryless. If you have some value here, amplitude here, then it is system with memory. Got it? Did you follow?
Yes, ma'am.
I'll repeat once again. For a system to be memoryless, a system is said to be memoryless. Okay, we are telling memoryless first. It will be memoryless if this condition, if these two conditions are satisfied, that is h of n should be 0 for n not equal to 0 for discrete time signals, and h of t is 0 for t not equal to 0 for continuous time signals. That means in a signal h of t, at t is equal to 0, you can have some amplitude or any value. But for other values of t or for other values of n, the amplitude should be 0. That time it's memoryless. If you have any amplitude to the left or right of the 0, then it will be a system with memory. Got it? Is it clear? This is categorization of system using impulse response. Did you get it?
Yes, ma'am.
So in input-output relationship, what did we tell? Memory, memoryless system. How did we classify that memory, memoryless? If output at any instant depends on input at past instance or future instance, then it is a memory-based system, right? So if y of t is equal to x of t minus 1 plus x of t plus 1, so present output, this is present output, it is depending on past input and future input. So these are the systems with memory, correct? Which we have seen previously. So when we are categorizing systems with respect to input-output relationship, okay? So y of t, if it is equal to x of t, present output was depending only on present input. So these are the memoryless systems. So what is another name for memoryless? Static, and this was dynamic. You recall these? Remember these things, what we had seen with respect to input-output relationship?
Yes, ma'am.
If present output, if it depends on past input, future input, or present input, it's memory-based system. If it depends only on present input, if present output depends only on present input, it's memoryless system, right? So for impulse response, so depending on the impulse responses, if h of n is having the value only at n is equal to 0, then it is memoryless system. If h of t is having a value only at t is equal to 0, it's memoryless system. Okay. If it has any value, any amplitude other than 0, if any other places, if you have amplitude other than 0, then it's memory based. Okay. Is it clear? If you have amplitude only at n is equal to 0, then it's memoryless. Similar, this is also for continuous time. If you have some value of amplitude at t is equal to 0, then it's memoryless system. Okay. H of t is equal to 0 for t not equal to 0. If you have any other amplitude values at other time instance other than 0, it's system with memory. Understood? Is it clear?
Ma'am,
Don't. Yes.
U of t will be memory or memoryless, ma'am?
For u of t, you have a system. You have values from 0 to infinity. So what type of system is that?
It will be memory.
Memory-based system. Okay. Like that, you have to understand. If you have amplitude only at t is equal to 0 or n is equal to 0, that is memoryless. If you have to the right of 0, to the left of 0, if you have any amplitude, that's the system with memory. Got it?
Yes, ma'am.
Others understood?
Yes,
So that is memory, memoryless. Coming to causal. So a system is said to be causal if it satisfies this property. H of n is equal to 0 for n less than 0 and h of t is equal to 0 for t less than 0. What is the meaning of this? Think, what is the meaning of this?
Minus infinity to 0, signal will be 0.
So h of n is 0 for n less than 0. For if it is from 0 to infinity, it should be 1. And here also it from 0 to infinity, it should have, if you have some value, then it's a causal system. Okay. H of n is having samples to the right of n is equal to 0 or to the right of t is equal to 0. That time the system is causal. There are no samples to the left of n is equal to 0. If this condition is satisfied, then it's a causal system. Understood? Is it clear?
Yes, ma'am.
So when it is non-causal, when do we call it as non-causal? If there are any samples, suppose you have like this, suppose you have some samples here also to the left of n is equal to 0, then it is non-causal. Okay, suppose h of t, we'll take one example. So if this waveform starts from 0 and it will go up to infinity, then it is causal. If you have waveform to the left also, then it is non-causal. Understood? There should not be any waveform to the left of n is equal to 0 or t is equal to 0 for a system to be causal. If you have any waveform to the left of t is equal to 0 or n is equal to 0, then the system is non-causal. Got it? It's clear?
Yes, ma'am.
Now we shall see
Can
stable.
you draw a little bit up, ma'am?
Yeah. H of n is equal to 0 for n less than 0. H of t is equal to 0 for t less than 0. Done?
Yes, ma'am.
Are you guys following? You have any doubts? So when we solve problems, we have to categorize the system based on stability, causality, memory. Okay, that time these waveforms will help us. So you have to you have to interpret that. How will the waveform look, and try to categorize it based on causality, memory, and stability. So stability we shall see now. What is the condition for stable system? So a system is said to be stable if the impulse response is absolutely summable or absolutely integrable. Okay, with respect to discrete time signal, if you have k is equal to minus infinity to infinity, modulus of h of k is less than infinity. So if the impulse response is absolutely summable, then it is stable. And with respect to continuous time signal also, if you have integral minus infinity to infinity, modulus of h of tau into d tau, if it is less than infinity, if it's absolutely integrable with respect to continuous time, and if it's absolutely summable with respect to discrete time, signal, and with respect to continuous time signal, then the system is said to be stable. Okay, so what is the meaning of this? Absolutely summable or absolutely integrable means what?
Finite values.
Finite values, right? So absolutely summable or absolutely integrable means the response is convergent. It converges to a value less than infinity. Okay. That means it has finite value. Okay, it has the value less than infinity. If you solve it, h of t or h of n or h of t will be given. If you try to solve that, you will get a finite value. Okay, so if you integrate our impulse response from minus infinity to infinity, then it converges to a finite value. That is the value less than infinity. Then it's a stable system. Got it? Clear? So y of t is equal to x of t convolved with h of t. So how do we write it? Y of t is equal to integral minus infinity to infinity x of tau into h of t minus tau into d tau. So we can also, it's commutative, right? We can also write integral minus infinity to infinity h of tau into x of t minus tau into d tau from the commutative property. Okay. So what is bibostability? So if you are giving bounded input, we have to get bounded output, right? What is bounded input? We are giving the input which is less than infinity. So we have to, so wait. So if input is equal to some value bx which is less than infinity, our output should be also equal to some value which is y of t which is less than infinity. So modulus of y of t is given as integral tau is equal to minus infinity to infinity modulus of h of tau into modulus of x of t minus tau into d tau. Got it? This is the condition for an output to be bounded for a stable system. Clear? So we are checking the bibostability, that is bounded input, bounded output. If our input is some value, finite value less than infinity, then output modulus of y of t is equal to integral tau is equal to minus infinity to infinity h of tau into x of t minus tau into d tau. This is the condition for the output to be bounded for a system to be stable. Okay, for continuous time signals, this is the equation. For discrete time signals, we shall see. For discrete time signals, you have summation k is equal to minus infinity to infinity. Modulus of h of k should be less than infinity. Okay. So if your impulse response is absolutely summable or absolutely integrable, then the system is stable. That is understanding from this. Got it, everyone? Clear?
Yes, ma'am.
So let us summarize whatever we have seen. You have classification based on these three systems mainly, okay? So for memory, what did we see the condition? H of n, h of n should be equal to 0 for n not equal to 0, and h of t should be equal to 0 for t not equal to 0. If this condition is satisfied, the system is memoryless. If you have values for other values of t other than 0, then the system has memory. Okay. That is the meaning of this. And for causality, what is the condition? If h of n is equal to 0 for n less than 0, and if h of t is equal to 0 for t less than 0, then the system is causal. That means it should not have values to the left. It should have values to the right side only. Then it is causal. If you have values to the left side, then it's non-causal. Okay. H of t or h of n is having values for n less than 0. If it has values for n less than 0 and t less than 0, then it's non-causal. Okay, that is about that. And for stability, the impulse response should be absolutely integrable or summable. Okay, it should converge to a finite value which is less than infinity. So that is the condition for stability. Got it, everyone? Clear? It's clear, these three classification of systems for impulse response. Is it clear, everyone?
Yes, ma'am.
What about others? It's clear? Shall we solve few problems on this? If you want a break, we can take a break of 5 minutes and we'll solve problems on this. Shall we solve or you want a break for 10 minutes?
Break, ma'am.
Okay, you can take 10 minutes. Or we can solve some problems for 10 minutes and wind up the class.
Yes, ma'am.
Yes, ma'am, you can continue.
Yes, ma'am.
Just leave us 10 minutes, sir.
Okay. So let us see some problems on this. I'll leave you. I'll solve few problems and leave you. We'll continue the problems next class. So take down first problem. H of n is equal to half to the power of n into u of n. Okay. So how will the signal look? H of n. How will the signal look? It will exist from where to where?
From 0 to positive side.
So you have unit step here. Unit step signal u of n will start from 0 and it will go up to infinity. Okay. It is multiplied with half to the power of n. So what is your h of n? H of n is a signal which is existing from 0 to infinity. Okay. So that is multiplied with half to the power of n. So give values for this n. If n is equal to 0, half to the power of 0 is 1. So at n is equal to 0, we have 1. At 1, you have half. And at 2, you have 1 by 4. At 3, you have 1 by 8, so on. Okay. So the waveform starts from 0 and it will go up to infinity. So if you had u of minus n, h of n is equal to power of n into u of minus n, but you have been given u of n, so it's existing from 0 to infinity. So what is the condition for a system to be memoryless?
It only at 0.
So the system, if h of n is 0 for n not equal to 0, it's memoryless. But since h of n is not equal to 0 for n not equal to 0, what type of system is this?
Memory based.
It's memory based system. First classification is memory. So it's existing at from 0 up to infinity. Okay. So it's not only existing at 0, it's existing from 0 to infinity. So our first condition is we have got to know that it's memory based. For memoryless, if h of n is equal to 0, for n not equal to 0, it's memoryless. Since h of n is not equal to 0, for n not equal to 0, it's a memory based system. Okay. Next classification is causal. Okay. So it's causal or non-causal, the signal.
Causal.
It's causal. H of n, since h of n is 0 for n less than 0, you can see you don't have negative values of n. So it's a causal system. Okay. Third classification is based on stability. So what is the equation? Summation k is equal to minus infinity to infinity. Modulus of h of k should be less than infinity. Okay, because it's a discrete time signal. So substitute the value of h of k. So k is equal to, k is existing from 0 to infinity in our signal, this h of n. So what is h of k? H of n is half to the power of n into u of n. H of k is modulus of half to the power of k into u of k. Got it? Clear? Half to the power of k into u of k. So you have summation k is equal to 0 to infinity half to the power, modulus of half to the power of k. U of k amplitude is 1, right? Unit step amplitude is 1. So we can substitute it as 1. So what is this? Which form is this? It is of this form, summation n is equal to 0 to infinity alpha to the power of n 1 by 1 minus alpha. So what you get? 1 by 1 minus half, which is equal to 2. So this is less than infinity. So the system is stable. Got it? Is it clear?
Yes, ma'am.
Okay. We'll solve one more problem and wind up. Do you understand how to categorize based on memory, causality, and stability? Impulse response. Okay, you take down this. H of n is equal to 0.99 to the power of n into u of n plus 3. So u of n plus 3 means from where to where it will exist. U of n plus 3.
From minus 3 to infinity.
So it will exist from minus 3 to infinity. Minus 3, minus 2, minus 1, 0, 1, 2, 3, up to infinity. This is u of n plus 3. So if you multiply 0.99 to the power of n, what will be your h of n? It is amplitude 1 here. So 0.99 to the power of 0 is 1. So at n is equal to 0, it will be 1. For 1, 0.99 to the power of 1 will be 0.99 only. So at 1, it will be 0.99. At 2, it will be some value still less. At 3 also, it will be some value less. What about at minus 1? Minus 2, minus 3. What will be the value at minus 1?
0.99.
Check once.
1 by 0.99.
What will you get?
Minus 0.999.
No, what is at minus 1? You'll get 0.99 to the power of minus 1. So it's 1 by 0.99. So it will be some value greater than 1 or not?
1.0101.
1.0.
Yeah, at 2, minus 2, it will be something greater than that. At 3 also it will be greater. So the waveform will exist from minus 3 up to infinity. Yes or no? No need to bother about the amplitude. Just check from where it will start and till what extent it goes. Okay, it will start from minus 3 and it will go up to infinity. So this is our h of n. Okay, so first tell me the categorization of memory. It has memory or memoryless? Since we have samples to the left and right of n is equal to 0,
Memory based.
it's a memory based. Since you have to write a statement, since h of n is not equal to 0 for n not equal to 0, it's a system with memory. Got it? Clear? Memory, it's clear?
Yes, ma'am.
Next you take causality. So it's causal or non-causal?
Non-causal.
It's non-causal because there are samples to the left
Non-causal.
of n is equal to 0 also. So since h of n is not equal to 0 for n less than 0, it is non-causal. Coming to stability, we'll try to check the stability. So stability equation for discrete time is summation k is equal to minus infinity to infinity modulus of h of k. Okay, it should be less than infinity. That is the condition. So we'll try to evaluate this summation. So you have summation k is equal to minus 3 to infinity, right? Our signal is existing from minus 3 to infinity, this h of n. Okay, so I put the limits of summation as minus 3 to infinity. So you have 0.99 to the power of k into u of k plus 3. We are replacing n with k, h of n with k. N with k, we are replacing, so we have got 0.99 to the power of k into u of k plus 3. So u of k plus 3 amplitude is 1. So you have summation k is equal to minus 3 to infinity 0.99 to the power of k. So try solving this. So to get rid of this minus 3, what you will do? I have taught you once. If you want to get rid of this, if you want to make lower limit 0, what you will do?
K plus m is equal to 0.
K plus 3 is equal to m. If k is equal to minus 3, m is equal to 0. If k is equal to infinity, m is also equal to infinity. Correct? So your summation limits will be from m is equal to 0 to infinity, 0.99 to the power of what is k? M minus 3. 0.99 to the power of m minus 3 into amplitude 1. Now I will split this. I'll take 0.99 to the power of minus 3 outside and summation of m is equal to 0 to infinity, 0.99 to the power of m. Solve and tell me what you will get. So you have 0.99 to the power of minus 3 divided by, this is of the form summation n is equal to 0 to infinity alpha to the power of n, which is 1 by 1 minus alpha. Alpha is 0.99. So you have 1 by 1 minus 0.99. What will you get this value? What is the value of this?
103.061.
0.6. That is finite value. It's less than infinity. So you can say that the system is stable. Got it? Clear, everyone? Is it clear?
Yes, ma'am.
So for a system to be stable, it should be less than infinity. Summation k is equal to minus infinity to infinity. Modulus of h of k should be less than infinity. So in our case, the waveform is existing from minus 3 to infinity. So h of k is nothing but h of n. 0.99 to the power of n into u of n plus 3. Replace n with k. We have 0.99 to the power of k into u of k plus 3. So u of k plus 3 means left shift. So it will exist from minus 3 to infinity with an amplitude 1. So 1 is the amplitude, 0.99 to the power of k. Now to make lower limit 0, you have to make k plus 3 is equal to m. So if you make k plus 3 is equal to m, if you replace k with minus 3 plus 3, m will be 0. If k is equal to infinity, m will also be equal to infinity. So k is equal to m minus 3. Okay. So summation you have got m is equal to 0 to infinity 0.99 to the power of k. So k is m minus 3 into 1. Okay, so split this 0.99 to the power of minus 3, take it out. Summation m is equal to 0 to infinity 0.99 to the power of m. So this is of this form, alpha to the power of n. So you have 0.99 to the power of minus 3 divided by 1 minus 0.99. So you'll get some finite value. So you can say that the system is stable. Okay. So one more hint for you. If the amplitude goes on diminishing, then it's a stable system because the system will converge to some finite value. Okay. So if the signal is converging, like in this case, our amplitude is reducing, so the system will be finite. Got it? The summation of h of k will be finite. Understood, everyone?
Yes, ma'am.
You have any doubts? You have any doubts?
No, ma'am.
What about others?
No, ma'am.
Vinay followed?
Yes, ma'am.
Okay. What about others? You have any doubts in the topics whatever we have discussed today? Rakshita, it's clear?
Yes, ma'am.
Okay. So we'll wind up this class. I'll stop the recording. If you have written your name and USN, write your name and USN. So tomorrow we'll solve some more problems on this.
Ma'am, everyone were asking about the quiz, ma'am. So when
Yeah.
will you conduct?
When will you take?
Ma'am,
Saturday?
they told something about MATLAB. What is the quiz? Is it MATLAB, ma'am?
No, no. One of your friend told me to show some demo on MATLAB, signals and systems.
Okay, okay.
So that demo I told, if you have any extra class or any free period, if you tell me, I'll show you the demo in MATLAB. How to use that software for signals and systems.
Okay, okay, ma'am.
That's it.
And quiz when will you conduct, ma'am?
Quiz, the portions will be unit 1. We had 4 sets of question papers. So all the problems are there in that. It was given for your internals only. So no need of unit 1. So shall we have unit 2 and 3 till whatever we have covered for quiz?
Ma'am, in 2 days, ma'am, 2 lessons, 2 chapters, ma'am.
Like convolution integral, convolution sum.
Ma'am, can you keep it like next week so that we can prepare?
Okay, fine.
Because we'll have lab and all, and then we have to submit the reports also. So we can't do it in 2 days, ma'am.
Okay, so let it be next week, but the portions is unit 2 and unit 3.
Okay,
Okay,
ma'am. Yes, ma'am.
and you'll not have differential equations. If I complete that, it will be there. If I don't complete, it will not be there.
Ma'am, otherwise
Okay,
next week tutorials last 15 minutes you can give us, ma'am. That time we'll have this.
okay, fine.
Okay.
I'll give you some problems only.
Okay, ma'am. Next week tutorials we'll have. That time you can conduct.
Okay, fine. Or else any Saturdays is also fine.
Ma'am, Saturdays we have class till 1 and then one they have diploma students have.
Okay,
So
fine. Next
only in the
Thursday,
morning or next week, ma'am.
yeah, next Thursday, we can have it after tutorials.
Okay, ma'am.
Okay. So you people study whatever is done, convolution sum, convolution integral, graphical method, formula method, and this one property methods you study, interconnection of systems you study, and these categorization of systems also you study. And we have one more topic, step response in this unit 3. So if we do that, I think it will be completed unit 3. Then I'll go to differential equations of unit 2. Are you guys following whatever is done till here?
Yes, ma'am.
You have any doubts? You want me to repeat anything? If you want me to repeat any problems, I'll do it after I complete these things. Okay. You can write your name and USN if you have written. If you don't have any doubts, then we can wind up this class. Thank you, students.
Thank you, ma'am.